Hi, so now we're looking at finding the inverse of a matrix. So I'm going to look at a generalized form before we do any questions with numbers in the matrix. So to find the inverse of a matrix, so we represent the inverse as we put the letter and then that negative one on top there. Like if you think about functions and you find inverse of a function, something like that. So to find the inverse of a matrix, we normally have to define the determinant of that matrix first. So it's 1 over the determinant of that matrix. Then we're going to multiply by a new matrix that we just are going to basically switch around some stuff from the original matrix. So you see that first diagonal has A and D in it, right? So that first diagonal with A and D, we are going to switch it. Basically, D comes where A was, and then A goes where D was. So you switch those two letters. And then for the second diagonal, you're going to put back those numbers, and all we're going to do is change the sign. So positive becomes negative. And that's how you find the inverse of a matrix. That's the generalized form. So now, let's look at a question. Let's say B is equal to 1, 5 and 2, 3. 2, 3, let's change this here to 4. 4, 2, 3, 5. So let's go ahead and find the inverse. So the inverse is 1 over the determinant. What is the determinant again? Remember that from the last few videos? 4 by 5, product of first diagonal. Take away the product of the second diagonal. Right, so 1 over the determinant. And now we're going to switch around the numbers in the matrix. So the first diagonal, you're going to switch those numbers. 5 comes here, 4 comes here. The other two numbers, put them as is, you're just going to change the sign. Positive becomes negative. And let's just simplify this here. So you get 1 over 4 by 5 is 20, take away 2 by 3 is 6. So that's 20, take away 6. I'll write it again here, and then write back the matrix. 1 over 14 over 5, -2, -3, 4. And you can leave your answer just like this. This is the inverse of matrix B. So now let's look at another question. So number 2. Let's say we have matrix X. Matrix X, let's say, is 4, -3, 7, let's say 2 here, right? So the inverse of matrix S. So as I said before, is 1 over the determinant. So let's find the determinant. So 4 by 2. Take away the product of the second diagonal, -3 by 7. And across here now we're going to switch around our numbers. So the 2 comes here, the 4 comes here. So the first diagonal, the two numbers switch. For the next two numbers, write them back. That -3 is going to become +3. You have to change the sign of the numbers. And then 7, +7 become -7. And let's simplify down here. 4 by 2 is 8. Take away. -3 by 7 is -21. Go back. The matrix, that one is already fixed. You can remove the positive sign here, because remember, this automatically means positive now, right? And remember, a negative and a negative is a positive. So I'm going to get A plus 21. My final answer now will be 1 over 29, and then name the matrix here. And that's how we find the inverse of a matrix.